guys, so now let's learn about the division models. There's three models that we're going to learn for the division of whole numbers: the repeated subtraction model, the partition model, and the missing factor model. So let's take a look. The first model we're going to look at is the repeated subtraction model. And just like with multiplication, we were thinking about repeated addition. With division, we're going to be thinking about repeated subtraction. These are inverse operations. So let's look at this problem. It says Ms. Rizlov has 28 students in her class whom she wishes to divide into cooperative learning groups of 4 students per group. So if we're thinking about the repeated subtraction model, here we can see it illustrated. It's sort of like that step model we were looking at in multiplication, only now instead of leaving each set in, we're taking them out. So we've got our 28 students in our class, okay? And you can see we've taken those 28 students, and these arrows mean that we're subtracting. So we're taking them out, okay? And we're taking them out in groups of 4 because she wants to divide them into groups of 4 students. So each time we take out one of these groups, right, we're subtracting 4. Oops. So you can see we just keep taking out a group and subtracting another 4, and then we take out another group and we subtract another 4, and take out another group and we subtract another 4, okay, until we have no students left to divide up, right? And once we do that, we wind up with 7 groups, and you can see that here, 1, 2, 3, 4, 5, 6, 7, okay, so we're taking out 7 groups of 4. So just like multiplication is repeated addition, division is repeated subtraction. We're figuring out, okay, well, if we're dividing into groups of 4, and this is my total, let's take out one group of 4. Then let's see if we can take out another group of 4. Let's take out that group of 4. See if we can take out another group of 4. Let's take out that group of 4. And by the time we're done taking out groups of 4, how many groups of 4 did we wind up subtracting out, right? 1, 2, 3, 4, 5, 6, 7. We subtracted out 7 groups of 4. All right. So we get 28 students divided by 4, and we're dividing them into groups of 4, which gives us 7 groups. So now let's talk about the partition model, which is division by sharing. When I think of the word partition, I think of like those walls, or like if you're sitting at your desk and there's a partition between you and the next person, there's like a divider between you guys, right? So that's what sort of helps me to remember what the partition model is. So let's look at this problem. Ms. Rizlov checked her supplies and discovered she had only 4 sets of manipulatives to use with 28 students in her class. How many students must she assign to each set of manipulatives? So we still have those 28 students, but now we are working with 4 sets of manipulatives. So we need to sort of divide these students up so that they each are working with a set of manipulatives. So let's see how we do that. So this is what it would look like. And if you look at those dotted lines, those are the actual partitions. So you draw these dotted lines, just like partitions that divide people's desks, like those little walls in between. These are like barriers that are dividing up our groups of students. Okay, so you would literally draw these partitions. And let's say we were starting this problem from the get-go, I would draw my partitions so that I have my 4 groups here, right? Here's 1, 2, 3, 4 that I can divide my students up in because I'm dealing with 4 sets of manipulatives. And then I'd literally just start placing students in each group. So 1, 2, 3, 4 until I got to all 28. 5, 6, 7, 8. So I'm just placing a student in each group, and I just keep placing them from first in the first group, then in the second group, then in the third group, then in the fourth group. Then I go back to the first group, second group, third group, fourth group. So that's 8 students so far, 9, 10, 11, 12. And I would keep placing them until I eventually placed all 28 students. And then I would look and I'd see, oh, okay, in each group I have 7 students. So for each set of manipulatives, 7 students are going to be sharing them. So that's the partition model. And then we see we had 28 manipulatives. We only had, 28 students who were sharing 4 sets of manipulatives, so 7 students are going to be in each group. So let's look at the last model, the missing factor model, which ties in really closely with fact families that we were working on. So this sort of stems from the definition of division, which is down here, okay? And I think if you look at this definition, it's sort of confusing. So let's talk about it. It says the division 28 divided by 4 can be viewed as finding the factor c for which 28 equals 4 times c. Okay, so we're saying 4 times what equals 28? That's how we can sort of solve this division problem, okay? So if we look at this picture I have here, we can use 28 tiles to form a rectangle with 4 rows. So you'll see that there are 7 columns in the rectangle. Okay, so if I've taken 28 and I've divided it into rows of 4, well then how many columns do I have? Okay, so I've got 1, 2, 3, 4, 5, 6, 7. Oh, okay, so 4 times 7 is going to give me 28. And this is just like what we did with partitioning, right? We took each tile, we placed it in a row of 4 until we had placed all 28 tiles. And then we saw, oh, okay, there's 7 tiles in each row. So we know 4 times 7 is going to give us 28. So 28 divided by 4 has to equal 7. Okay, and that's what this definition is saying. So for A and B that are whole numbers, as long as B doesn't equal 0, because you can never divide by 0, you will get an undefined answer. Then A divided by B equals C if and only if A equals B times C. So if there is some number that we can multiply by B to get us back to A. So again, this can look a little confusing, but if we think about it in this more visual way, I think it's a lot more understandable. Again, knowing your fact families here is really handy. Let's look at an example of the missing factor model. I have 20 M&Ms and wish to give each of 4 friends the same number of M&Ms. How many M&Ms will I give each friend? This is a frequent occurrence in my home, which is why this example came to mind, okay? I have 3 children and we often have a friend who comes over, so we are always dividing things up among 4 friends. So anyway, and M&Ms happen to be a hot ticket item in this house. So it's just like the partition model, you guys. So again, so we have 20 M&Ms, we're dividing them by 4 friends. So how many M&Ms is each friend gonna get? What number do I multiply by 4 to get me back to those 20, right? So how am I going to do this? Well, I'm going to partition these up. So I have my 4 friends. So I've got my 4 rows. 1, 2, 3, 4, right? So now let's divide up our M&Ms. So we're just going to go through and partition these up. So you get the red one, you get the yellow one, you get the orange one, you get the blue one, and then we'll keep going with all the other M&Ms, okay? So we've got our 4 groups. And we're trying to figure out, well, how many M&Ms are we going to have in each row, okay? Or another way to say that is how many columns will we have when we are finished partitioning? So once we finish partitioning, it winds up that each of our friends is going to wind up with 1, 2, 3, 4, 5 M&Ms, okay? So we had our 4 groups, 1, 2, 3, 4, our 4 groups, and then we wound up with 5 per row. So 1, 2, 3, 4, 5, which gave us our 5 columns, okay? So here's how it all partitioned up. 4 groups with 5 columns. So I take my 20 M&Ms and line them up in 4 groups. How many end up in each group? 5, right? Do they line up evenly or are there some remaining? And so in this instance, they lined up evenly, right? Each friend is getting an even amount, thank goodness. Otherwise, the fighting would ensue. But as you're going to see in our next example, sometimes that doesn't happen. So let's take a look at that. What would happen now if I needed to divide them into 6 groups, those same 20 M&Ms? All right, so what would happen if I needed to divide them into 6 groups? Well, now let's say 2 extra friends came over, okay? So we have our 2 new friends down here. So now we have 1, 2, 3, 4, 5, 6 groups that we need to divide these M&Ms. So we're gonna go, you get red, you get yellow, you get orange. We're gonna start partitioning. You get blue, you get green, and we're gonna keep going. And when we do that, of course, now we have our 6 groups. So let's see how many we're going to have per row. So now once we've done that, we see that, okay, well, each of my 6 friends wound up with 3 M&Ms. We had 3 per row or 3 columns, as you can clearly see, but now we have a remainder of 2. And we're going to talk about remainders in more depth as we go on. But it's important to note that when we took our 20 and we divided by 6, we wound up with 3 with a remainder of 2 M&Ms. And Mom gets those elusive 2 M&Ms, right?